15.1, we're going to do it in 2 sections. Today's part 1, tomorrow's part 2. You guys are going to have a quiz on this next Wednesday. It'll be multiple choice. You can use your calculators, but you need them. All right, the first thing we're going to talk about is the fundamental counting principle. What I want you guys to take away from the fundamental counting principle is you're going to multiply everything together. Multiply everything together. When we have the fundamental counting principle, we multiply. All right, you guys got that? So, suppose there's these 3 towns, A, B, and C, right? And it says this is like a word problem. They're located in a way. How many different ways can you get from Ashbury to Brampton and all of these roads that connect? The way that you would figure this out mathematically, right? Yes, you could go, okay, well, I can go this way, and then I can go that way, and then from there I can go this way, or this way, right? That's called finding a sample space. Sometimes it's easy to list out the sample space, sometimes it's not. But if you notice, guys, here, there's 2 ways to get from point A to B, right? This is A and this is B. And then there's 3 ways to get from B to C. You guys see that? Well, the fundamental counting principle says figure out the ways you could do one thing and then the other thing, and then you multiply them together. So how many different ways could you follow these roads? It's 6. We don't add. It's not 5. But your fundamental counting principle is we're going to multiply. So this is the explanation here. From Ashbury to Brampton, from A to B, there's 2 choices. And then for each of those choices, there's 3 more that follow. So then your 2 times 3 is 6. You're always going to multiply. You'll see problems like this, like you are going to college, and you can take 4 sciences, 3 maths, 2 Englishes. What do you do with those numbers? You multiply them together. That's the fundamental counting principle. This is finding the sample space. Lots of times you guys can do this when you're like tossing coins. Finding the probability of something like that. You can write out all of the different ways that it could happen. When there's only 6, it's not that hard, but when you get up to when there's like a million different ways something could happen, you can't write them all out. So that's why we use the fundamental counting principle, or we use something called permutations and combinations. So, like I just said, the fundamental counting principle, it occurs in m times n ways. What do we do when we use the fundamental counting principle? What do? We multiply, okay? Remember that, please. That's very important. So think about this. An ice cream store offers how many different types of cones? 3 types of cones. And how many different flavors? 31. Now, to find the sample space, okay, say there's sugar cone, a cake cone, and a waffle cone. You could say, okay, sugar with chocolate. And then you could say sugar with vanilla. And you could list everything out, right? Wouldn't that take a long time? Would you be able to get all of the combinations? Probably not. So what you do is you take the first, there's 3 types of this, there's 31 types of this, and you get a total of how many different ways could you make these cones? 93 ways. Okay, so when we use the fundamental counting principle, you are multiplying together. We'll do a whole bunch of different kinds of problems over the next few days to illustrate this. We'll come back to this later on. All right, let's say this pizza parlor offers, well, let's talk about subs, right? You're at Publix, you're getting a pub sub, right? There's 3 different breads. There's 4 meats, 6 cheeses, and then 12 different kinds of veggie toppings. How many different sub combinations could you make? Well, you could list out, okay, there's white, wheat, and then underneath you could put ham, white, ham, wheat, ham, right? And try to get everything. Would that be virtually impossible for you guys to list every single different combination? So using the fundamental counting principle, we say, okay, there's 3 different breads, 4 different meats, 6 different cheeses, and 12 different toppings. So guys, calculators, what's 3 times 4 times 6 times 12? There's 864 different combinations you could make at this sub shop. Does that make sense? Okay. Good. All right, now we're going to talk about something called permutations. A permutation, right here, is a set of distinct objects in an ordering of these objects. What I want you guys to understand from this is a permutation order, I spelled it wrong, order matters. Another way I think about this is different jobs, okay? Not just the word different, but everyone is doing a different job. Now, listen to what I mean by this. If you are running in a race, does order matter? Or do we all just run and who cares if you win or lose or whatever? No, right? There are specific places, first, second, third. If you're running for student council, vice president, president, secretary, everybody has different jobs. You're doing it something else. If you're in a school play, somebody's going for this position, someone's going for this position. That would be where you use permutation. Now, there is a formula for permutation, which we've talked about before, and combinations. But you guys have a button on your calculator, the NPR button. It's also the NCR button. You need to know where that button is and how to use it so then you can understand how to find the answers to these. So you're not writing out the whole thing. Yep, that's perfect, because you're going to need to know the difference between a permutation and a combination. That's the biggest thing from these lessons. I'll show you in one sec. Yep, PBR. Yep, I'll show you. Yeah, yes, PRV, that's what I meant. Here is, here is the formula for a permutation. It's very similar to combination, which we just had on our last quiz. But you use a permutation when order matters. Think about this. If you're going to the movies with 5 of your friends, right? There's 5 seats to sit in. Can you all sit in the first seat? No, someone has to sit in the first seat, then someone has to sit in the second seat, so someone has to sit in the third seat. That's why it's a permutation, because order matters. Now we're going to do a bunch of problems to see this. So look, a club has 9 members, and how many ways can a president, vice president, and secretary be chosen from this club? Well, how many people total are in the club? 9, right? How many different positions are there? 1, 2, 3. Does order matter, or does everyone get to be president? Order matters. So this would be a permutation. Think about it. There's 9 people. 5, 6, 7, 8, 9. How many people could possibly be the president? 9. Then once the president is chosen, how many's left over? 8. Then how many's left over for the next position? 7. It goes all the way down, right? So if you're just worried about the first 3 places, you would, in your calculator, hit 9, the P, and then the 3. It's the permutation button, not the combination button. When order matters, it's the permutation.
So which one would it be?
How many? 504. If you were to write it out this way and did 9 times 8 times 7, it's still going to be 504. But the big difference here is, it does order matter or not. If you have, let's talk about, well, let's not do distinguishable permutations. Hang on a second. How about if we talked about, you have a multiple choice test, all right? Multiple choice test. It's a 5-question test. You can choose answers A, B, or C. All right, let's think about this. What does this look like? There's 5 questions. 1, 2, 3, 4, 5. How many different ways can I answer the first question? 3, right? Okay. How many different ways could I answer the second question? 3. What about the third one? Then. What would you do with all these numbers? You multiply them. That's the fundamental counting principle. It's 3 to the 5th power. That's how many different ways you could answer that question. You guys see that? If we talk about something called distinguishable permutations, right? You will usually see this when we talk about letters and words. Usually see this when we talk about letters and words. Let's go to back to this one. 15 different balls that you have in a given row, right? There's a total of 15. How many different ways can you arrange them? Well, what is repeated? There's 4 red, right? So 4 factorial. 6 are yellow. Nope. 6 are black. 3 are yellow. 2 are blue. Do that in your calculator. See if you guys can do that. Does everybody know where their exclamation point is? Is anybody listening? Thanks, Hapka. Yeah, you can just do it manually. Just break it down a little bit. Good word. So this would be 4 times 3 times 2, right? Times 6 times 5 times 4 times 3 times 2 times 3 times 2 times 2 times 1. It did give you the answer? All right, what'd you get? 6306 300. If you input it correctly, you should get the answer in your calculator. Yeah.
Good job, Malera.
I know, she's on it. Slide and then we'll come back, all right? Given the word grammar. How many letters are in the word grammar? 7. What do you notice about some of the letters in the word? They repeat. All right, when you are ever asked for distinguishable, it's the total number factorial, we know what factorial is, over the repeated factorial. So how many letters are in the word grammar? 7. So 7 factorial over, what's repeated? Okay, what's repeated? R how many times? So 2 factorial. Then what else? M twice. Then what else? R twice. So you could do that in your calculator. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And then 2 factorial just means 2 times 1, 2 times 1, 2 times 1. Or you could use the factorial button in your calculator. That same button that has the PRB. You have 7 with an exclamation point. It's not a very excited 7. We remember what factorial means. And then it's divided by 2 factorial, 2 factorial, 2 factorial. Make sure you put the denominator in parentheses. Hi. So you tell yourself, I know. We have a quiz next week. You tell yourself that, or you tell the calculator that 7 is divided by whatever's on the bottom. Because your calculator is only as smart as who? Who's your calculator only as smart as? I told you guys before. As you, as the user. Good. All right, so one more.